Hey, this is Mr. Alexander, and I want to talk to you about IB subtopic 1.8. It's currency conversion and compound interest. It's actually IB subtopics 1.5 and 1.8. And what we've got here is two types of problems. We've got converting currency from one currency to another, and we've got investing money. How much is it worth after so much time? Let's start with some IB questions here. The first one I've got is the following question, question 7 here. The following table gives the exchange rates from US dollars to euros and from US dollars to Japanese yen. Give all answers correct to 2 decimal places. Enrico has 475 US dollars. How many euros is this worth? So the way I always think about these problems is you start with 475 US dollars. And you want to set up a ratio for the others where on the bottom of that ratio is 1 US dollar. We want to put it on the bottom of the ratio so that that US dollar cancels out with that US dollar, leaving us with only whatever unit this is. In this case, we want euros, because that's what we're trying to convert to. And I'm told that 1 US dollar is worth 0.6337 euros. Now, all we got to do is multiply straight across, and with fractions, it's straight across. This is 475 over 1, so I'm essentially doing 475 times 0.6337. When you do that calculation, you find that you're left with 301.01 euros. Okay? Enrico goes to a bank to exchange his dollars. The bank charges 3% commission. How many euros does Enrico receive? Well, if I figure out what 3% commission is, I'm going to take 0.03 times the euros that he got, 301.01, and that's just about 9.03 euros. So instead of the guy getting them, it's going to go directly to the bank. So the amount he actually receives is that 301.01 minus the 9.03. He's going to actually receive 291.98 euros after the bank takes their cut. The last thing we're asked to do in this IB question is find the exchange rate from euros to yen. So when I get over here, when I'm done, I want to know how many yen there are for every 1 euro. So I want to end up with a proportion here. That'll give me the exchange rate. So on this side, I want to have 2 ratios. The first one, I want to have yen on the top and euro on the bottom, so that my answer is yen to euros. Which means that here we've got to have US dollars and US dollars, so that these US dollars will cancel out. My exchange rate's 1 for both of these, and I just need to fill in the missing information. So for every 1 US dollar, there's 99.7469 yen. For every 1 US dollar, there's 0.6337 euros. So essentially what we're doing is 99.7469 divided by 0.6337. So that means for 1 euro, I'm getting 157.40 yen. So the exchange rate from euros to yen is 1 euro for 157.40 yen. I'm going to skip over to question 9 because that's another currency question before we do question 8. And in question 9, it's a slightly more sophisticated question because we're told that this guy arrives in Singapore, and at the airport he changes 800 euros to Singapore dollars. The bank rates quoted at the airport for exchanging euro to Singapore dollars are given in the following table. Also given are the rates for exchanging Singapore dollars with British pounds and US dollars. There's no commission charged. So you've got this bank buys and bank sells. And this chart's always going to tell you what the bank's doing. And the little trick I use to figure out which one to use is we're going to use bank sells when we're going from local currency to foreign currency. In this context, the bank is in Singapore, so Singapore dollars is the local currency. Everything else is foreign. So conversely, we're going to use the bank buys when we're going from foreign currency to local currency. And that's how you're going to know which column to use. When in doubt, do them both. Use both the exchange rates and pick the one that's a better deal for the bank. That's always the right answer. The bank always wins, and so whichever exchange rate's better for the bank, that's the one you're supposed to be using. So I'm supposed to calculate the number of Singapore dollars this guy receives after exchanging his 800 euros. And since we're going from foreign currency to local, we're going to use the bank buying formula here. So we're going to have our 800 euros. We're going to use our proportion. And on the bottom, we're going to have euros. And on the top, we're going to have Singapore dollars because it's exchanging for Singapore dollars. So the question is, what's the exchange rate from Singapore dollars to euros? We're using the buying. So it's going to be 1 euro on the bottom and 1.55 Singapore dollars on the top. So we're essentially multiplying 800 times 1.55. That's 1,240 Singapore dollars is the answer for that one. All right, part B is a little bit more complicated because it's a two-step procedure. Pietro also has 100 Great Britain dollars, or pounds, British pounds, I should say, that he wishes to exchange to US dollars for a trip to Cambodia. To perform this transaction, the Great Britain pounds must be converted to SUD and then to US dollars. So we're going from foreign to local back to foreign. So foreign to local, we're first going to use the buying rate, and then in the second step, we're going to use the selling. So because we go from pounds, foreign to local, that's buying, local to foreign, that's selling. So when I set this up, I've got 100 British pounds, and I want to first convert that into Singapore dollars. So I've got my pounds on the bottom and my Singapore dollars on the top. And the rate I'm going to use is from the buying, because it's going from foreign to local. So that I know 1 Great Britain pound is equal to 1.92 Singapore dollars. Now in the second step, we're going to be converting, well, I've already canceled out Great Britain dollars, so I know I'm going to cancel out Singapore dollars for US dollars. So I want to use the exchange rate for US dollars and Singapore dollars, but this time I'm using the selling rate because now I'm going from local currency to foreign. So I know for every 1 US dollar, I'm getting 1.28 Singapore dollars. So the mathematics here is we're multiplying 100 times 1.92 and then dividing it by 1.28. When you do that, you get 150 US dollars. So that one is a little complicated, but hopefully you understand the logic. Let's step away from currency. I'd like to talk about investing and financial applications, which is all calculator work here. And let's talk about Pierre now. He's got 5,000 euros in a fixed deposit that pays a nominal interest rate of 4.5% compounded monthly for 7 years. Calculate the value of the investment at the end of his time. Correct 2 decimal places. So the trick here is to use the financial calculator, and it's always under the apps 1, 1. That's the way I remember it. Apps 1, 1 to get to the financial calculator. It said 7 years, and the interest rate was 4.5%. He's got 5,000 euros. Always keep the payment at 0. I'm trying to find the future value. Always keep the payments per year at 1. The compounds per year, it says compounded monthly, which would be 12 times per year. So to figure out the future value here, I'm going to do alpha, enter, ignore the negative sign. It's going to be 6,847.26 euros is the answer. 6,847.26 euros. So no math involved there, just let the financial calculator handle all the heavy lifting here. Carla has $7,000 to invest in a fixed deposit, which is compounded annually. She aims to double her money after 10 years. What's the minimum interest rate she needs? All right, so our present value, they say is 7,000. And it's going to be 10 years, so n equals 10. And we're trying to double it. It's compounded annually, so let me change these compounds per year to 1. Trying to double it. 7,000 doubled is 14,000, which you need to enter as a negative. And I want to know the minimum interest rate, so I'm going to go up to the I% and do alpha enter. She's got to get at least 7.18% to achieve her aim. So you can see that these compounding questions are significantly easier than the currency questions. Let's do one more since we have the time. And the one I'd like to do is let's do number 6 here. That one looks good. Hussein invests 20,000 Egyptian pounds in a bank that offers a rate of 3.1% per annum compounded monthly. Calculate the amount of money Hussein has in the bank after 5 years. So now our n is 5. Getting 3.1% per year. Started with 20,000. And it's compounded monthly, so the compounds per year is 12. It bears repeating. Leave p/y at 1, leave the payments at 0. Alpha enter on the future value. Hussein has got 23,348.49 Egyptian pounds. All right. Last one we're going to do here. Find how many years that it will take for his money to double. So instead of the future value being 23,000 here, we're going to change it to negative 40,000 because 20,000 double is 40,000. Now if I go up to the n and do alpha enter, I can see it's going to take 22.4 years to double. But since it's compounded monthly, it's kind of arguable. You might also suggest that it's 23 years to double. Alright, that's it. Either one of these answers is fine. That's all I've got in this video. Thank you for watching. We'll see you next time for gradients and equations of lines.